one of the key skills with learning to work with quadratics is actually being able to draw them. Because as we learnt from looking at our applications of quadratics in a previous lesson, if you can see the graph, then it's much easier to understand what's actually going on, and therefore you have a chance of actually interpreting the mathematics that you're doing and coming up with an answer that actually solves the problem or answers the question. So we're going to look at sketching quadratics, and we're going to use just the standard form in this particular video. We're going to look at the turning point form in a subsequent video. But for today, we're just going to focus on the standard form. Now, whenever we graph any function, but in this particular case, we're obviously focusing on quadratic functions, then we need to identify the same sets of points for every graph. Now, some graphs will have extra points that we need to identify, but for a quadratic, for a quadratic, we worry about exactly two of the things that we used to look at for a linear function, and that is understanding the y-intercept. We find the roots, and for a quadratic, we look for the stationary point. We look for the turning point. Where does it turn around on the axis? So, how do we do that? Well, the process is exactly the same in most cases as it was for the linear function. All right, so we're going to identify the three different areas. So here's an example. Sketch the graph of y equals 2x squared minus 5x minus 3. So we're going to identify three different components of this graph. The first one is our y-intercept. We do the y-intercept first, basically because it's the easiest. And we know on the y-axis that x is equal to 0. Nothing new there. That's exactly the same as the process we followed for linear functions. So if we're going to graph this function, determine the y-intercept, if our function is y equals 2x squared minus 5x minus 3, we let x equal 0. So we're going to go 2 lots of 0 squared minus 5 lots of 0 minus 3, and we get minus 3. So our y-intercept is negative 3. So on my graph, as I determine pieces of information, I'm going to plot them on my graph. So there's negative 3 down here. Okay, and so there will be my y-intercept. So I'm going to put a big point there. So there's my first piece of information. Okay, the second piece of information are my x-intercepts. And this is the area of math that we've been working on for the last little while. Okay, finding the x-intercepts. In other words, as you very well know, we're looking for the roots. So you've got plenty of different ways you could solve that. So what I'm going to do is I've set up the function. I would like you to pause the video, and I would like you to find the roots of that equation. Now you can choose any method you like. So whether you choose to do your roots by factorizing, or you choose to find your roots through the quadratic formula, either way, you get your two solutions. And so we know the roots are x equals a half or x equals 3. So I've gone ahead and I have marked on the graph those 2 points. Get rid of that dotted line. Okay, so we've got those 2 points and we've labelled them on our axes. So the final piece of information that we need to find is the stationary point. Now the stationary point, as we know, falls on the axis of symmetry. And the axis of symmetry is exactly halfway between my two x-intercepts, or my two roots. So how do I find halfway between them? Well, the x value is going to be equal to negative a half plus 3 divided by 2, exactly halfway between them. So I just add the 2 divided by 2, and if I do that sum, I get 1 1/4, or 1.25. Okay, 1 1/4. And so that point there is going to be sort of around about there. So let's put the dotted line in there for my axis of symmetry. Okay, so we've got that. Now again, if you like, 1 1/4 is the same as 5 on 4. And you know how much I like fractions. So we'll leave it as 5 on 4. Now, again, we need a stationary point. A point has 2 pieces of information, an x value and a y value. So how could I find the y value? Well, I go back to my equation, which says y equals. So it's going to be y equals 2 lots of 5 on 4 squared minus 5 lots of 5 on 4 minus 3. Just triple check I've got that correct. Yes, okay. So now we're going to work this out. So again, if you've got a calculator, put it in your calculator and get your answer. Whether you use fractions or you use your calculator, you should get negative 6.125. So my turning point, or my stationary point, has a set of coordinates at 1.25, negative 6.125. Okay, they're not very nice numbers, but that doesn't matter. So negative 6.125, so there's 3, 4, 5, 6, so it's around about there. So I'm going to label it, so 1.25, negative 6.125. Okay, so once we've got that point, we can have a look at our graph. Now we can see that the only way that that graph is going to be able to drawn is if the graph looks like this. So we can put our line in, it's got quite a sharp turn, and up she goes again. Not the best parabola in the world, but not too bad. Now, just a couple of quick things as an aside, okay, and you'll come across these as we go. There's a couple of little secrets you can do to help you with your sketching. Secret number 1, and we'll discuss this as to why in a future video. We have briefly talked about it in a previous lesson when we were talking about the quadratic formula and the discriminant. But if we think about the quadratic formula, I'll just quickly write it again. B squared minus 4ac all divided by 2a. Now, we talked earlier that if the discriminant was equal to 0, right, so now if this area of the graph was equal to 0, then we only have one turning point. Oh, sorry, one root. Apologies, we only have one root, and that one root is the turning point. So therefore, we can calculate the turning point, or the stationary point, or its x value, by using the formula x is equal to negative b over 2a. All right, again repeating, when the discriminant is equal to 0, then we only have one root, and in order to draw a parabola, the only place that one root can be is the turning point. So therefore, there's a little formula to calculate the turning point. Now, if we look at our particular calculation, b in our function is negative 5, and then a was 2. So negative of negative 5, so in our example, b was equal to negative 5, and a is equal to 2. So x is equal to negative of negative 5 over 2 by 2, which is 5 on 4. So that's another way that you could calculate your turning point. So either axis of symmetry or that little formula. Okay. The second little piece of information is this. If a is greater than 0, then we have a minimum. Now we know what a is. A is the coefficient of x squared. And if a is less than 0, then we have a maximum. So that's just another little clue. Now, as we work our way through these graphs, you'll see that holds true every time. All right? They're just two little extra pieces of information to help you with your sketch. Once you've identified those three key areas, y-intercept, the roots, and the stationary point, then you can graph your quadratic.